There's a routing issue you need to be aware of regarding inter-network SIP calls, particularly when routing between an internal network and an external network. It's an issue caused by network address translation, or NAT. Now, you'll be familiar with the notion of private networks assigning private IP addresses to internal private devices, addresses from specially designated ranges used repeatedly by networks all over the world. A packet from this 192.168.0.10 sent to 192.168.0.11 goes here, and a packet from this 192.168.0.10 to 192.168.0.11 goes here. Both packets are privately routed to private addresses within their private networks. Now, as well as having private IP addresses, each private network also has a globally unique public IP address with which to interact with the outside world, an address assigned to some kind of border controller, perhaps a firewall or an SBC, that maps internal private addresses to the external public address through something that's known as network address translation. For example, surfing the web from my 192.168.0.11 address, when I enter a URL, well, my packet will be routed first to the border controller as the exit point from my private network to the public network. Well, let's do it capturing the packet en route. Okay, start capture, sipsense.com, and here's the request. Now, I see at the application layer that it's an HTTP request addressed to host sipsense.com. And I see at the IP layer the packet's sourced from my internal private IP and that it's destined for sipsense.com's public IP address. Now, before sending this request out to the public network, my border controller, knowing that my private address here is not publicly routable, on my behalf performs network address translation, swapping out my private address for my private network's public address, mapping the address translation as it goes. Receiving the request, the remote server returns the response back to the packet's source address, routing it where? Exactly, not to my device, but to my network's border device, which in turn queries its address translation map, resets the destination address at the IP layer, and routes the response back to my device. Clever. So the border controller acts as network address translator, translating, mapping between internal private and external public IP addresses, modifying source and destination addresses at the IP layer. So how does this apply to SIP, and what are the issues? Remember, basic NAT translates source and destination IP addresses at the IP layer. Now watch this. I'll load up my SIP client, start the capture and call out to an external SIP address. I'll cancel and OK, here's the SIP request. And at the application layer, I see all the SIP headers, all the SIP routing addresses. And at the IP layer, I see the same source address. Knowing that basic NAT changes addresses at the IP layer, well, the SIP packet goes out to sipsense.com looking something like this. Now, do you foresee any problems? Where will the SIP response be routed? Not back to the source address at the IP layer, but to the via address at the application layer. With basic NAT, SIP breaks right away, with the response address being unroutable from the public network. So what's the solution? Well, one way is to use a more advanced SIP-aware border device that can perform NAT at both the IP layer and the application layer. A SIP-aware network address translator receiving that same packet from a moment ago not only translates the IP layer source address, but also the application layer via header and contact header. Then, on receiving the request, this time the response is routed back to the via header to the border device, which in turn remaps back to private addresses at both the IP layer and the application layer, routing the response back to my device. Nice. Or is it? That alone may not be enough. In fact, some years back I was helping run a SIP application developer event with one of the big UK carriers, in which we needed to make SIP calls out to an external network. Now, we were aware of network address translation issues, or so we thought, and had made sure we had a SIP-aware firewall at the network's border. Sure enough, the call set up just fine with routable 200 OKs coming back just as expected. But there was never any audio. Why not? We asked ourselves. Well, take a look again at the SIP packet. Why, after successful SIP network address translation, did the audio stream fail? It was because of the SDP. Although the SIP-aware network address translator had indeed translated the SIP addresses, it had not gone down to the SDP layer, had not translated SDP routing addresses, resulting in audio destinations being unroutable. So beware that border controllers must be able to translate at both the SIP layer and the SDP layer. In the next lesson, we'll be looking at session border controllers. Now, most good SBCs these days perform network address translation at the IP, the SIP, and the SDP layers of the packet. But what if I have only basic NAT at my border device rather than a nice SBC? Is there any way to use basic NAT and get SIP to work? There is. We can use STUN. STUN standing for Session Traversal Utilities for NAT. Now, STUN works on the notion that if ahead of time a SIP client knows the private network's public address, it can pre-populate SIP and SDP addresses accordingly. Now, the captured packet might look something like this, with at the IP layer the actual private source IP address, but at the application layer the pre-populated external address. Think about it. Basic NAT translates only at the IP layer, paying no interest to any addresses at the application layer. But we don't care. They're already set to the network's public address by our STUN-capable SIP client. Now, receiving the request, the remote user agent server routes the response back to the address in the VIA header, to my network's public address to the border controller, which in turn then remaps only at the IP layer, routing the response back to my client. Nice. So how does my client find its private network's public address? By querying a STUN server. There's many to choose from. If I ping what'smypublicip.com, the remote server simply returns the external source address of my packet. So to use STUN, a SIP client must be able to first ping a STUN server for its public address and then pre-populate its routing headers, both SIP and SDP, with that public address. So, in summary, network address translation enables multiple devices inside a network, each with their own private IP address, to share a common external public IP address. However, basic network address translators translate addresses only at the IP layer, not at the application layer, meaning that SIP routing addresses like the contact and the VIA headers will not be translated and will therefore be publicly unroutable. SDP addresses must also be translated, else calls may initiate, but without any media exchange. So be sure to use a NAT device that knows how to translate at the IP layer, the SIP layer, and the SDP layer. An alternative is to use STUN, where the SIP client queries a STUN server for its external address and then uses it to pre-populate its application layer SIP and SDP routing addresses. So basic NAT takes care of translating at the IP layer, leaving the application layer addresses already populated with valid publicly routable addresses.